Hello and welcome to another EasyRoads3D tutorial video. In this episode, we will be looking at how you can use your own intersection or crossroad models within the EasyRoads3D system. In the introduction video, we saw that EasyRoads3D supports two different connection types: dynamic built-in connection prefabs and custom connection prefabs. Dynamic built-in connection prefabs are generated by the tool itself. Connections like X and T intersections and roundabouts. These built-in options are constantly being worked on and expanded with new features. But like in the real world, intersection situations and variations are endless. That is why this custom connection system was one of the first features that we added to the new EasyRoads3D version 3 workflow. It can be used to import your own connection models into the EasyRoads3D framework. By being able to import your own models, you are not limited to what is provided by the tool itself. Additionally to that, road objects attached to these connections will inherit the shape of the custom connections. This unique feature opens doors to endless possibilities for creating other infrastructures, for example railroads. We will have a look at that in this video as well. The free demo package on the Unity Asset Store, which we also used in the introduction video, includes various examples. We will look at some of these examples and show how each of these prefabs use specific features of this custom connection system. So all available custom connection prefabs in the project are listed here in the inspector toolbar. They can be added to the scene just like built-in connection prefabs, by selecting them in the inspector and shift-clicking in the scene. Just like with dynamic built-in connection prefabs, new roads can be pulled out from the individual connections. And roads already in the scene can snap to these connections. To achieve this with your own models, connection zones can be assigned to the prefab so the system knows where roads can connect. Let's see how this works and how we can turn mesh models into ready-to-use custom connection prefabs. It is very easy. We can do this in the Custom Connection Editor window, which can be opened from the Crossing Connection Prefabs section in the General Settings tab. For this first detailed example, we will use the railroad crossing model in the demo package. This prefab includes two different connection types, and it is an example of how we can create other infrastructures like railroads with this custom connection system. So in this case, we modeled a crossroad between a road section and a railroad. We used a section of the secondary road type in the demo package, and added the railroad section resulting in this model. The object can be dropped from the project folder in the source object slot, or directly in the Custom Connection Editor window. The mesh will appear in top-down view. Let's first have a look at how we can pan and zoom. We can pan around by pressing the left mouse button. And we can zoom with the scroll wheel or the left and right mouse button and move the mouse up or down. Provided that this window has focus, pressing the Z key will center the prefab with the focus on the full mesh. The mesh appears in top-down view. This is what you want. If that is not the case, then it means that the model in the project folder has rotations. This can be checked by dropping the model in the scene and look in the inspector for possible rotations on child objects. To deal with these rotations, we can change the trace on axis. In that case, it is also necessary to recalculate the normals and tangents. But ideally you want to avoid these steps and export the model from your modeling app so no rotations are applied in Unity. So we have our mesh clearly visible. First, we will create the new connection prefab in the project folder by pressing Build Connection Object. The prefab is now available in the Custom Prefabs folder. This prefab can always be edited in a later stage by dropping it in the Custom Connection Editor window. We will see this later when we will be looking at some of the other custom connection prefabs in the demo package. The next step after building the connection object is defining the areas where roads can connect. Let's start here with the first railroad connection. Press the Shift key, left click and drag a rectangle around those vertices that should also be part of the connection. The selected vertices will light up in green. We can also see the selection in front view, which can be a useful reference for custom shapes like this railroad. We will now assign a road type to the connection. All road types that match the selected shape, or the number of selected vertices, will be listed here in the Road Types dropdown. When no matching road types are available, it will display none. In that case, or when the road type for this connection does not exist yet, we can create a new road type directly here in this window. By creating the new road type right here in this window, all settings including the connection shape will be stored automatically for the new road type. We can enter a name and press Add. The new road type is created and available in General Settings, Road Types. And also in the New Road Object tab. A material for the connected road can be assigned if we create a new road type. After that, we want to check or set the UVs for the connected road. This is done in the UV editor window, which will show the road texture of the selected material as a clear reference. By default, the UVs will be distributed by distance between vertices. Optionally, we can use planar UVs, eliminating height differences. Copy UVs from source mesh will copy over the UVs of the selected source mesh vertices. This option can be used when the material for the crossing connection is set up to also work well on roads. The RA crossing prefab and RA road type is an example of that. We will look at that later in this video. In fact, this will also work well for this railroad, and we want to select that because we have two similar rail shapes, and the vertices will share the same UV coordinates. When using the default UV distribution by distance, the UVs can be fine-tuned here on the canvas. To set the UV coordinate of a node, press the left mouse button. The orientation will switch to front view, and the selected node will be highlighted as a clear reference. Drag to move the node position to the desired position. We can repeat this for each node. In this case, we want to use the UVs of the source mesh, so let's press that button again. Hard edge is source mesh vertex specific, and therefore read-only. It is only visible as a reference. When all nodes are set, we can press Close. At this point, all connection data is set. We can continue adding more connections by pressing Add Connection, and repeating this process. What is important here is that connections are added in the clockwise direction. This requirement is mainly terrain deformation related. When the connections are not added in clockwise direction, the terrain may not be adjusted correctly to the connection shape and position. We started here, so in clockwise direction, this is the next connection. A connection for road objects. Once again, select the vertices by pressing the Shift key, and left-click drag a rectangle around all the vertices that should be part of this new connection. We can see that for this connection, there are road type matches. This connection prefab is intended for the secondary road type, so we select that road type. Because we selected a road type, there is no need to set materials and UVs, as this will be inherited automatically from the selected road type. We can already see that here. The material points to the secondary road material. The next connection in clockwise direction will be the railroad on the opposite side. We created a new railroad road type for the first connection, And indeed, it is now available for this similar railroad connection. Let's finish the setup for this prefab and do the last connection as well. So that is all for the connections. Here we have the terrain related options. This is a connection prefab for which we do want the terrain to update, so we keep terrain deformation switched on. The new custom prefab is now ready to use. We press apply to save the changes. Let's add an instance into the scene and test the setup. We select the prefab here in the inspector and shift-click in the scene. The workflow for these mesh-based custom prefabs in the scene is the same as for built-in dynamic prefabs. Roads that are already in the scene can be attached, and new roads can be pulled out. This works well for all 4 connections. For the railroad connection, we see that indeed the shape matches the railroad shape from the connection. At this point, only the railroad itself is generated. We can complete the setup by adding railroad ties or sleepers as side objects. We already have a mesh type of side object for this ready. The railroad tie prefab is spawned every X units. This is all customizable here in the Side Object Manager. In the demo package example, we also activated a side object for the ground below the railroad. This side object is based on a shape type of side object, a simple 2-node shape on top of the terrain. And a pebbles material is assigned to the material slot. After activating these side objects for the railroad road type, we can press the Update Scene Instances button. The railroads we already added will be updated accordingly. So this is how you can import your own connection models and use them within the system, and optionally with additional side objects activated. To complete the setup of this particular prefab, we can also add railroad crossing signals to the prefab in the project folder. We can do that by opening the generated connection prefab in the Unity prefab editor. We place a railroad crossing signal prefab here. And another one here. And after exiting the prefab editor, we can press this button, Update Childs in Scene Instances. This will update all scene instances. Let's have a look at the final result in build mode. We raised the railroad crossing a little bit above the terrain, and we can see that the terrain indeed adjusted to this custom connection prefab, just like with the dynamic built-in connection objects. So that is how we created the railroad connection in the demo package. Let's switch back to edit mode and have a look at other examples of custom connection prefabs in the free demo package. Here we have two types of on and off ramps. These models were generated from the integrated on and off ramp system we are currently working on for version 3.3. We can have a quick look at the setup of these connection prefabs. As mentioned earlier, to see and edit a custom connection prefab, we can drop the by EasyRoads3D generated prefab here in the window. We can see that for this prefab, 3 connections are assigned. When connections are not vertically or horizontally aligned, the vertex rectangle section can be tricky. In this case, there is enough room. But when that is not the case, then we can rotate the mesh so the rectangle selection does work well. We can see here which road types are assigned. And in the scene indeed, these road types are used when pulling out new roads from these connection objects. Another example is the RA prefab. This prefab includes sidewalks as part of the crossing and will generate a road type that also includes sidewalks and parking lanes. This is another example of how different road or spline shapes can be generated with custom mesh-based connection models. And this connection prefab is also an example of how the crossing connection UVs can be used on the attached roads. The RA road material texture has a setup where the same texture space is used for both sidewalks. So these are all different examples of custom connection prefabs. They are part of the demo package, so you can look at them, see the setup, and get familiar with this system. Then, for your own models, you may want to start simple. For example, with a unity plane primitive. That is an easy way to quickly test creating connections with different vertex counts and see how roads inherit the shape. The next step is creating your own custom connection models. It is recommended to start with one, the easiest, and test it here in the system before continuing modeling the next one. For example, when it turns out that roads cannot connect to some connections, it means that the shapes do not match. To check this, the stats of the connections can be compared. The numbers should be the same for similar connections. The mesh extraction system is pretty robust, but one thing to pay attention to are these dots. They represent extracted mesh edges, edges where roads can connect. These extracted mesh edges can be inside the mesh, but it is good practice to avoid that they connect with the outer edges, because this can potentially result in wrong vertex edge order and issues with terrain deformation and connected roads. Take this model and look at the triangulation. These are dots, extracted edges inside the mesh that connect with the outer dots. You want to avoid this type of triangulation near the outer edges. To fix this, we need to change the triangulation. For example, like this, we can see that there are no longer dots inside the mesh. Apart from adding connections in clockwise direction, this is the only requirement. And in any case, if you do experience difficulties with your own models, you can always contact us. We will be happy to help. So that concludes this video about the custom connection system and integrating your own models within the EasyRoads3D framework. We hope you enjoyed watching it. We will be back soon, so if this video was helpful, then do subscribe to this channel right now, and we'll see you in the next video. Thank you for watching.